We are back, day 2, everything about geometric sequence. What we did for day 1 was we just looked at what is a geometric sequence, what makes it geometric, what does the equation look like, and so for what we're going to be doing today is we're going to look at a geometric sequence and see if we can write the equation, or if I give you the equation, see if you can write out the long sequence. And we call that transferring between the different ways to write it. So our essential question will be, can I transfer, sorry that was loud, between equation and sequence? So for my geometric sequences, can I go from the sequence to the actual equation, the equation to the sequence back again? Now let's quickly kind of dissect again, what does the equation look like? We have A and a B, because once we figure out what the A and what the B is, then we have our equation and we need to be able to go back, and if I have my equation, how do I use those A's and those B's? A in this case is zero term. So the zero term is actually never in the sequence. The sequence is first term, second term, third term, so the zero term is actually invisible in the real sequence. And then B, in this case, is my common ratio. Meaning, what is it being multiplied by? What's being multiplied every single time? It might even be a fraction. Is it being multiplied by 1/2 or getting smaller and smaller and smaller? So the common ratio, don't know why it has that little thing there. That should just say ratio, not ratio. I don't know why it says that, but common ratio there. So we kind of quickly did a little review there. Now let's see if we can actually go between them. For today's assignment and following assignments, you're going to see these, I don't know what to call it, like a grid maybe. So the first thing that you're going to see is f of 0, which, if you remember, is your zero term. So you're going to put your zero term here. You're going to put your whole sequence here. Maybe the sequence might even be given to you, and that will be there. And then finally, in the last column of our grid, will be the actual function or the equation. So sometimes the equation will be given to you, you got to find the sequence. Sometimes the sequence will be given to you, you got to find the function. In this case, again, I'm going to write that my zero term is A, and that B is my common ratio, or multiplied however many times. Again, what is with, why do I keep writing that? I don't know why. Okay, so the question I'm going to write in black, so like what would be given to you, and then I'm going to do all my work as a student in orange. So I hope that makes sense to you. But for example, online or for a problem, you might see something that looks like this. Where did my example go? Here it is. So you might see something that looks like this. It gives you that your first zero term is 3. It wants you to fill out the sequence, let's say 5 pieces of the sequence, the first 5 numbers. That keeps going, obviously, but only the first 5. And it's going to give you the function, the actual equation, how it's written. Okay, there we go. So I know my zero term, done, and the zero term is out in front. So I want to just remind all of you that this is the first term, this is the second term, this is the third term, fourth and fifth. This is not your zero terms. 3 doesn't go here. 3 goes out like it's like invisible, so it would never actually be in your sequence, which is why we write it here, just as like a little reminder. And then 2 is your common ratio. So 2 is what you're multiplying by every time. So we're going to multiply by what? We're going to multiply by 2. Multiply by 2, and what do I get? 3 times 2 is 6, and keep going. Multiply by 2. 6 times 2 is 12. Keep going. Multiply by 2 is 24. Multiply by 2. Multiply by 2. Fill that out. Okay. I would like you to pause the video right now and make sure you have everything for example 1. even like these swoops where it says I'm going to multiply by 2, multiply by 2, multiply by 2, etc. Because this orange is what you need to be able to do on your own. You need to be able to fill out a sequence if I give you the actual function or the actual equation. And I'm going to do one more like that with you. Ooh, I don't know what I'm doing. Filling in pens here. Okay, so in this case, I'm not technically giving you the zero term. You're going to have to figure that out on your own. But it's really easy because I'm going to give you the equation, which is 1/3 times 3 to the power of x. So let's dissect this. We know that we have our zero term. I'm just writing this down as like a reminder to us. 3 is our common ratio. So the zero term is easy. Plug it in. It's 1/3. That's what goes here. The zero term is not your first term. Your first term is your first term. That didn't make any sense. Sorry. The first term is term number 1. It's your first term. Maybe that was right. But it's not your zero term. Your zero term is not included. So if I said go from here to here, you would not start with 1/3, which is why I like to add this first column to be like, okay, it's 1/3. And we're going to keep the pattern going then. So our common ratio is 3. That means that's what we're multiplying by every single time. So we're going to multiply by 3. What is 1/3 times 3? You can use a calculator, although I really hope that you know 1/3 plus 1/3 plus 1/3 is 1 whole. It's 3/3, which is 1 whole. And keep going. Multiply by 3. Multiply by 3. Multiply by 3. Multiply by 3. Do you have to write these scoops anytime? I guess not. I'm not there to police you, but it's my suggestion for you to write that down. So far we have done problems where I'm giving you the equation or giving you this function and you are writing the sequence. In fact, I'll do this in pencil. So you're going from equation to sequence and equation to sequence. Whereas for our next two examples, if I give you the sequence, can you write the functions? We're gonna go backwards. So let's do number 3. I'm definitely going to run out of room with our little maybe I won't. Maybe we'll squish it. So I'm not going to give you the zero term. I do want you to fill that out on your own. But what I'm going to give you instead of the actual function over here is I'm going to give you the pattern, which is 12, 36, 108, 324, and I'm not going to fill that in. That's going to be something else you need to fill in. And then the rest. Whoops, that shouldn't have been there. Well, whatever. That's totally fine. Something out in front and then something else to the power of x. That's just a blank. It's whatever your zero term is. So I need my a or my zero term. I don't know that. I also need my common ratio. I don't know what that is either. I need to know what the common ratio is, what I'm multiplying by. So let's just take a peek. How did I get from 12 to 38? Or 36, that wouldn't make sense. 12 to 36. What did I multiply by to get from 36 to 108? And hopefully it's the same thing. And in this case, it happens to be 3. Although one way, I gotta reach over and grab my calculator here. So I do want to show you a foolproof way is, okay, so I could do what's 12 times 2? Nope, it's not 36. What's 12 times 3? Oh, it's 36. So I could just do that every single time and say, well, if I multiply that by 3. Yep, multiply by 3. So you could do a guess and check, or you could also just take those two numbers and divide it and go backwards. So 36 divided by 12 is 3. 108 divided by 36 is 3. So it gives you those numbers either way. You can figure that out. So in this case, similar, you take, just keep multiplying. Oop, I don't know what I was doing. So 324 multiplied by 3. Keep going. That is 972. So my common ratio I figured out was 3. And then the last thing I need is my zero term. So my zero term is what goes out here, is this backwards piece. So my zero term, I'm asking this question. What times 3 is 12? And you can do the same thing. You can do 12 divided by 3 to keep going backwards. So if you multiply by 3 this way, you can also divide by 3 to go backwards, which is 4. And that's your zero term. And I'm going to say this a million times. When you cross this out, that is that's your sequence. This 4, this 1/3, that 3 that you can't see up here, that 3. are zero terms, but they're not actually part of the sequence. Okay, so at this point, I'm going to use that pencil again. Instead of going from function to sequence, we went from sequence to function. And I'll do one more example for you there, too. Number 4, 100% running out of room. That's okay. I'm going to actually give you it, which is -2, -4, -8, blank, blank, which I'm going to make you fill out. Okay, so we got some blanks here. This is what your assignment will look like on Schoology. You'll just have blanks everywhere. And you need to figure out what to plug in where. So let's really dissect this. Firstly, I need a common ratio and a zero term. Well, I shouldn't say firstly, that's literally all we need. So we need a zero term, we need a common ratio. Common ratios are easier to find in this case, I think. That's my personal opinion, but that's what I think is true. Because that just says, how do I get from one to the next? And I gave you some clear ideas, like you could just say, you could just do, okay, it's times 3. Nope, it's not times 3, it's a little bit smaller. Times 2, yep. -4 times 2, yep, times 2. And you could just keep going there and say, okay, well, at least I know that it's -2. Oh, +2. Ah, oopsies, that's +2. It's not -2. Do you want to know why? Because look. -2 times -2 would be a +4, not a -4. So that's my mistake. It should be a +3. Whoopsies. Sorry. So that's awesome. I'm going to multiply by 2. I'm going to multiply by 2. I'm going to keep going. That's a -16. I'm going to multiply by 2, which is -32. And I can keep going there. So I think that the common ratio is easier to find in this case because you just find what's being multiplied and you can do some guessing and checking, or you can go backwards and divide. Like for example here, you could take -8 and divide it by -4 and figure out that it's 2, like you could go backwards. So then you ask yourself, what goes here? If I was to continue this pattern backwards, what would go there? And in this case, you could almost do it backwards and say divide by 2, divide by 2, divide by 2. -2 divided by 2 is -1. Or you could also ask yourself, what times 2 is -2? And just figure it out that way. So your zero term is -1. And if we just kind of reflect here a little bit and figure out what we've been doing, you need to be able to go from an equation to a sequence, and from a sequence back to an equation.